Susie is investigating the amount of time students spending watching TV. She randomly selects a sample of 50 students from the school and asks them the following question. Right, so there's questions here. I'll do it one by one. Pause the video if you want to try for yourself. Right, so first one in red. Give a reason to support using a histogram to represent the amount of time students at her school spend watching TV. Now I say time is a continuous variable and histograms are good for continuous variables. And that's it. Right, for B, complete the histogram. Now this says frequency. This says frequency density. They are not the same. Please do not think they are the same. Now, because this is not really in the normal form, I like to put down the boundaries of this class. So the lowest one there is 1.5 and the highest one is 2.5. 2.5 to 3.5. 3.5 to 5.5. 5.5 to 7.5. 7.5 to 11.5. Okay. Now we could do the class width and we need the frequency density. Okay. So my class width here is 1. There's 1, 3, 4, 5, 2, 5, 6, 7, which is 2, 7, 8, 9, 10, 11, which is 4. Frequency density is your frequency divided by your class width, which is 14. Good, that matches up to this. 11, 4.5. This one here is 2.5, and that's 1. Okay, now we need to plot these. This one here is 2.5, which is there, and it goes all the way up to 7.5, so that's 7.5 is there. And it looks a bit weird because it's not strictly where we'd normally be drawn if we drew it ourselves. And the other one is going to be the height of 1. That's 2.51 is going to be there. And it's going to go all the way up to 11.5, which is there. Okay. Now, a student is selected at random from those in the sample who's watching less than 5.5 hours of TV. Estimate the probability the student would watch less than 2 hours of TV last Saturday. So less than 5.5. Okay, so you just think, that's actually, I can just read that off my thing because 5.5 is going to be these 3 people here. Yeah, so 14, 11, and 9. Okay, so that's my entire range. Like people above 5.5, they are not included. Now we want the probability is less than 2 hours. So less than 2 hours is actually exactly halfway between that on there. Okay. So essentially this has got a height of 14, yeah, which is there, and I think that length there is estimated to be 0.5. So there's only 7 people who are less than 2 hours. So 14 plus 11 plus 9 is 34. So it's going to be 7 over 34. Type into my calculator, and that stays as it is. Okay. Right, so using the midpoint, Susie calculated the mean time spent watching television to be 4 hours. She concluded that the mean time spent watching TV in full days must be 7 hours for all students. Assess how Susie's question might affect the accuracy of the mean time. I'd say because she used midpoints, that's not accurate, that's an estimate. So for example, the group 4 to 5, everyone could actually be 4 hours of TV. And then you've actually put the midpoint of 4.5. Okay, and I'd also look at the questions. I'd say there's no options to do like 1 box 0, so 1 hour, 0 hours, above 12. Okay, all students, you got to focus on that one there because she's looking at students in a school, so it's just students that she spoke to. Okay. And she also says each day, yeah, which really the question is really just for Saturday. Yeah, so there's quite a lot of things wrong with that one there. Assess how Judy's method for collecting data affects the validity of her conclusions. Okay. Well, first of all, I'd say that it's a random sample, yeah, which is good, which means everybody's got a good equal chance of being selected. I'd say, however, it is from her school, so that means you can't really apply those findings to the wider context. You can only really do it to her school. I'd say last Saturday as well means that you can't be applied to other days in a week. And that's about it. That's all the questions.